All right, page 281. This is chapter 4, lesson 4. This will be our halfway point when we're done with this. We are going to multiply mixed numbers, nothing too new, just dealing with mixed numbers and improper fractions a lot. And it is still the snow day. Wow. And here is the village. We had the chapel, we had the school, we had the dough shop. This is one of my favorites. This is the candy shop. So look at that. It is the, oh wow, that's upside down. There we go. There's the candy shop sign. And look in the window. So cool. Yum, candy. All right, that was the first one I ever got right there, the candy shop. Okay, on to math and the giant squid, which I do love giant squids. Okay. The eyeball of an Atlantic giant squid is about 12 times as large as the average human eyeball. So giant squids have huge eyeballs, and I think they only have one. The average human eyeball is 1¼ inches across. Use a diagram to compare the average size of a human eyeball to the average size of an Atlantic giant squid's eyeball. So we're using this diagram to compare. This is the human eyeball, and the squid is 12 times that, and we're going to use some repeated addition. So we have to do 12 of these to equal the squid eyeball. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you have 1¼ so these are a bunch of human eyeballs, 12 of them to be exact. 12 eyeballs side by side of a human would be one giant squid eyeball. Wow. Imagine that. Now, how long is it then? If this is 1¼ this is inches. How long is it? Well, you have 12 holes. So you've got 12 holes. Plus you've got all these quarters. So 4/4, 4/4 is 1 hole. So 1, 2, 3, that's 1. Those 4 1/4, 1/4 gives you 1 hole. These 4/4 give you another one. And then these little 4ths give you another one. So it's 12 holes with the 1s plus 3 holes when you add up all the 4ths. So it should be about 15 inches. I'm thinking a squid eyeball on average is a good 15 inches, which is creepily over a foot. Let's go to number 2. Write a multiplication expression that shows the size of the Atlantic squid's eyeball. So we did 1¼ times 12. So I'm going to put 1¼ times 12. Now it would be okay to say 12 times 1¼ too, because of that commutative property. So either one of these makes sense. Write the multiplication expression from exercise 2 using improper fractions. Multiply to find the size of the squid's eyeball. So improper fractions, let's talk about those. We know that the 12 as an improper fraction is this. But how do we do the improper fraction for here? So you have this 1 right here is like saying 4/4 plus 1 more 4th would be 5/4. So this is like 5/4. So I'm going to do this. 12 times 1¼ 12 times 5/4. Okay, so this is the 12 and this is the 1 1/4. Now multiply across. Wait, can we simplify? Can't do that, but look at the 4 and the 12 here. Divide by 4. 4 divided by 4 is 3. 4 divided by 4 is 1. 12 divided by 4 is 3. Now multiply across. 3 times 5 is 15. 1 times 1 is 1. That's 15 inches, which is what we got up here when we did repeated addition. So we can use the same trick that we used in the last 2 lessons We just need to make sure that mixed numbers, when we multiply with mixed numbers, that they get turned into improper fractions. Once you have an improper fraction, you can simplify and multiply across and you're golden. So our trickiest part of this lesson is going to be turning mixed numbers into improper fractions. Everything else we've already been doing. So this on the next page says multiply a fraction and a mixed number. That's going to be the lesson that we just talked about. Same rule to multiply across after you have an improper fraction. And then multiplying mixed numbers. So over here, one of your one of your factors is just a regular fraction and one is a mixed number. Whereas over here, both of your factors will be mixed numbers. So that's the difference between this side and this side. So before we start anything, I think we should talk, well, I guess let's read this first, and then we're going to need to talk about mixed numbers turning into improper fractions. So, to multiply a fraction and a mixed number, first, write the mixed number as an improper fraction. So this is our first thing. Write the mixed number as an improper fraction. Remember that when mixed numbers are written as improper fractions, the denominator does not change. Okay? Then multiplies with fractions. So then you multiply across. And you also want to simplify, right? So the trick is turning the mixed number into an improper fraction. So let's do that right now. Here's how we do it. Maybe you remember. So you have this title, change a mixed number to an improper fraction. That's going to be our big heading. Now, let's show it first. So this was 2.5. 2.5. Now, what you have to do is you take 2 times 2 plus 1. So the first step is to go this way, 2 times 2. The second step is to go this way, plus 1. So 2 times 2, do first, that's why I'm putting in parentheses, then do plus the numerator. 2 times 2 is 4. 4 plus 1 is 5. And then it says, remember that when mixed numbers are written as improper fractions, the denominator does not change. So it's 5 halves. So 2 1/2 is 5 halves. That's the improper fraction. That's the mixed number. This is why this method works, because you have 2 wholes plus a half. So if you have 2 wholes, that's like saying you have 4 halves plus 1 more half equals 5 halves. So 2 wholes plus 1 more half is 1, 2, 3, 4, 5 halves. Now, if you're writing out those steps, the first thing you do is multiply the denominator by the whole number. The second step is we add the numerator. And the third step is write that answer over the original denominator. So multiply denominator by the whole number, add the numerator, and then write that answer. So 2 times 2 is 4 plus 1 is 5. Write it over the original denominator. All right, once you become an expert on that, all of this multiplying fractions with mixed numbers is super easy because we just we turn them into improper fractions and multiply like normal. So game on, here we go. 1/3 times 1 3/4. So we're going to write that in simplest form. 1/3 times 4 times 1 plus 3 is 7/4. 1 times 7 is 7. 3 times 4 is 12. There was no way to simplify before, so that's as simple as it gets. All right, now the estimating, now that we're having a little bit of bigger numbers, it makes a little more sense. 1/3 is close to a half. 1 3/4 is close to 2. Half of 2 is 1. And, ooh, that I don't think is very close to the estimate. Whenever we estimate fractions, it just seems to be a little off. Let's try to do the estimate here. So 5 1/2, I guess I'm going to round up to 6. 1/3, 6 times 1/3. Oops, sorry about that. 6 times 6/3. Well, what's 6/3? 6 divided by 3 is 2. So our answer, our product, should be close to 2. Let's see. 5 1/2 times 1/3. We need to turn this into an improper fraction. 2 times 5 is 10, plus 1 is 11 halves. So multiply across. 11 times 1, 2 times 3. We can't simplify either of those. 11 times 1 is 11. 2 times 3 is 6. Okay, now let's make it into a mixed number again. So 11 divided by 6, it only goes in there once, with 5 as a remainder. So it's 1 5/6. Now 1 5/6 is pretty close to our estimate of 2. All right, let's do these two. 2/3 times 2 1/2. So 2/3 times 2 times 2 is 4, plus 1 is 5 halves. Simplify this. 2 divided by 2 is 1. 1 times 5 is 5. 3 times 1 is 3. 3 goes into 5 once, with a remainder of 2/3 left over. So that's 1 2/3. Okay, what about this? 3/8 times 3 times 3 is 9, plus 1 is 10/3. 3 times 10 is 30. Oh, wait, we can simplify. Sorry about that. That would have gotten ugly. 3 divided by 3 is 1. 3 divided by 3 is 1. These can both divide by 2. 10 divided by 2 is 5. 8 divided by 2 is 4. 1 times 5. 4 times 1. Sorry. So 4 goes into 5 once, with 1/4 left over. It's so much easier to simplify before you multiply. If I hadn't caught that, we would have ended up with 30 over 24 and had to deal with simplifying that. So it's way easier to do simplifying with small numbers. Okay, so that was multiplying a fraction by a mixed number. We're going to do the same thing over here, but 2 mixed numbers. To multiply 2 mixed numbers, write each mixed number as an improper fraction. Use the greatest common factor to simplify, and we want to simplify before you multiply across. That's the happy way to do it. So 1 7/8 times 3 1/3. 8 times 1 is 8, plus 7 is 15/8. 3 times 3 is 9, plus 1 is 10/3. Now simplify. 15 and 3 both divide by 3. 8 and 10 both divide by 2. 5 times 5 is 25. 4 times 1 is 4. 25 divided by 4 is 6, with a remainder of 1. So 6 1/4. Number 4, the Hoover Dam contains 4.5 million cubic yards of concrete. The Grand Coulee Dam in Washington State contains 2 2/3 times as much concrete. So how much does it contain? This times 2 2/3. So 4 1/2 times 2 2/3. 2 times 4 is 8 plus 1 is 9. 3 times 2 is 6 plus 2 is 8. There are improper fractions. Now simplify. These two can both be divided by 3. These can both be divided by 2. 3 times 4 is 12. 1 times 1 is 1. So your answer is 12. So there are 12 million cubic yards of concrete in the Grand Coulee Dam. When they estimated here, they said this is about 4 and this is about 3. You could have said 5 and 3 and had 15 too. So it's a little bit, again, estimating with fractions is a little tricky. Not always as close as you want it to be. So Mr. Wilkins is laying bricks to make a rectangular patio. The area he's covering is 15 1/2 feet times 9 3/4 feet. So you have to do length times width to get the area. So we need to do 15 1/2 times 9 3/4. Let's turn these into mixed numbers. 2 times 15 is 30 plus 1 is 31 halves. 4 times 9 is 36 plus 3 is 39 fourths. Now, can we simplify is the question. You can't divide 39 by 2. You cannot divide 31 by 2 or 4. So this is kind of weird because you can't simplify. So 31 times 39, I'm going to do that over here. 9 times 1, 9 times 3, placeholder, 3 times 1, 3 times 3, add those. All right, 1,209. 2 times 4 is 8. Now, what will our mixed number be? So we have to do 1,209 divided by 8. 8 goes into 12 once. Bring down the 0 5 times. Bring down the 9. 8 goes into 9 once with a remainder of 1. So this would be 151 1/8 square feet. Man, that was pretty intense. We haven't had one with such big numbers yet. Cool. All right, Mr. Conrad. Last example here. Mr. Conrad's pecan pie recipe calls for 1 3/4 cups of pecans. He plans to make 8 pies for his family reunion. How many cups of pecans will Mr. Conrad need? So each one needs 1 3/4. He's making 8 pies. So 1 3/4 times 8 pies. 1 3/4, 4 times 1 is 4 plus 3 is 7. 7/4 times, and then you just put the 1 underneath that whole number to turn it into an improper fraction. Look at, you can simplify, divide by 4. 7 times 2 is 14. 1 times 1 is 1. So he needs about 14 cups of pecans. Pretty easy peasy. I think you're ready. Guided practice, here we come. All right, guided practice. We are doing 1, 2, 3, and 4. So turn this into a mixed number and multiply across. Don't forget to simplify before if you can, which I don't think you can on this one. Go ahead and try it and then check with me. Okay, so we have 1/2 times 8 times 2 is 16 plus 3, 19/8. Now you can't divide 19 by 2 and you can't, so we have to just multiply across. 19 over 16. So 16 goes into 19 once with 3 as a remainder. So this is 1 3/16. What about number 2? We need to turn both of these into improper fractions. 4 times 1 is 4 plus 3. 7/4 times 5 times 2 is 10 plus 4, 14/5. Now, we can simplify. We can divide both of these by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. We can't simplify those. 7 times 7 is 49. 2 times 5 is 10. Oh, man. So 49 divided by 10, that's going to be 4. Oh, yeah. With 9 as a remainder. That's crazy. 4 and 9/10. All right, number 3. Go ahead, pause it and do it and then check it. 1 times 3 plus 2. 7 times 2 plus 4. Simplify. Okay, can't do that. 3, yes, 18 divided by 3 is 6. 5 times 6 is 30. 1 times 7 is 7. All right, so 30 divided by 7. 7 times 4 is 28 with a remainder of 2. So that is 4 and 2/7. What about the story problem? Melanie is training for a track meet. She ran 2 1/4 miles 5 times this week. So she did 2 1/4 miles 5 times. 2 1/4 times 5. That would be 4 times 2 is 8 plus 1 is 9. This 5 over 1 can't simplify. 9 times 5 is 45. 4 times 1 is 4. So how many miles did she run? 45 divided by 4. 11 and 1/4. So she did 11 1/4 miles. Awesome. Independent practice. All right, let's circle these. 1, 2, 4, 5, 7, 8. Got to turn the mixed numbers into improper fractions. Simplify before you multiply. Let's look at number 7. A carp, that's a fish. A carp can travel at a speed of 3 7/10 miles per hour. At this rate, how far can he travel in 2.5 hours? So he can do 3 7/10. What's that times 2.5 hours? Oops. So go ahead and work that one out. Or this one, Juliet is making fruit salad. She purchased 9 2/3 ounces each of 6 different fruits. So how many ounces of fruit? 6 different fruits, each one was 9 2/3 ounces. So 9 2/3, 6 times. Work that one out. All right, so number 1 on the independent practice ends up being 1/2 times 7/3, which is 7/6, which is 1 1/6. Number 2, 1 7/8 is 15/8 times 4/5, and you can simplify those before you multiply. 3/2 is 1 1/2. Number 4, 5/3 here, 5/4 here. You can't simplify before you multiply. 25/12 is 2 1/2. And then 3 3/4 is 15/4. This is 12/5. You can simplify before you multiply. 9 over 1 is 9. Number 7, 3 7/10 is 37/10. 2 1/2 is 5/2. Simplify before you multiply. 37/4. And that is 9 1/4. And number 8, 9 2/3 is 29/3 times 6 over 1 gets you 58 over 1 if you simplify before you multiply. 58 ounces. Okay, reflection. All right, so Chapter 4, Lesson 4, multiply mixed numbers. To write a mixed number as an improper fraction, what do you have to do? How do you turn a mixed number into an improper fraction? Write these mixed numbers as improper fractions. When multiplying mixed numbers, I need to write the mixed numbers as blank, blank before multiplying. Here's how I multiply and write the problem in simplest form. So go ahead and do those 4 out. Show your work, answer in simplest form. And then you can finish that off by doing the learning objective check-in middle column for multiplying mixed numbers.